right, let's continue on with these annuity payments. So we're going to now invest $500. So that's going to be my recurring payment, that R. My interest rate is going to be 0.063, and it's compounded quarterly, so N is 4. And we want to know how much they're going to have when they're 60 years old. So it's tempting to plug 60 in, but right now we're age 40. So I would do 60 minus 40 to give me 20. And that's what I'm going to plug in for T. So I'm going to put that 20 right here in for T. Again, I'm going to make sure and be really careful with the calculator. I'm going to plug in this entire numerator. That gives me the 2.49 number. Plugging in the denominator gives me that decimal. Do not round your decimals. Once I have my two crazy decimals, I can type it in. You can just use parentheses here in your calculator to get my answer of $79,078.51. Now, an annuity is making steady payments on something. So every single quarter, we're putting in $500. So let's say that when we hit 60, we can't put in any more money. Maybe we're going to go ahead and retire and we don't have money to put in. So I'm going to take this $79,078.51 now to work B because I'm no longer making the monthly payments. So now that answer that I just got from part A is my P down here. That's my principal. Our interest rate's going to stay the same. We're still doing quarterly. But now I'm going from 60 to 65, so T is 5. 65 minus 60 gave me the 5 right here. This is a different formula because I'm no longer making deposits. This formula accounted for me continually to put money in. Now I'm not. I'm just going to not touch my $79,000. If I don't touch it for 5 years, then I'm going to end up with $108,092.38. So not bad at all. We're going to keep with the same formula, but now we're going to have to solve and figure out how much we need to deposit each one of these regularly scheduled payments or deposits here. So let's say we want to have $20,000. So that's going to be my S. Remember, that's that time travel thing where we're going to have to solve for the missing variable. So I need to invest this 10 years from now. So I'm trying to figure out what I need to do now. So I'm going to plug this 20,000 in for S, and I'm going to be solving for R. I want it in 10 years, so my T is 10. And let's see, it says compounded quarterly. So N is 4, and my interest rate is 0.068. So this looks very similar to the solving for P problem that we saw with the compound interest. Type it in my calculator very carefully like I did before, not rounding at all until I get to the ends, like my answer I'm going to box in. So when we get down to this step right here, I need to solve for R. Just like before, I need to solve for P. So I'm going to divide. I'm going to take that little cheating thing so I don't have to write it all out. Don't actually round. I'm just not going to write them all out. So I'm going to put the little ellipse there. You're going to divide both sides by this 56 point, and you're going to type in all the numbers in your calculator because you'll have room. On this computer screen, I just do not have room to write them all out. So we're going to take the 20,000 divided by 56.62521,009, and that gives me my answer. This answer means I need to deposit $353.20 every quarter. If I do that 10 years from now, I'll have $20,000 for whatever my goal was to have it for. All right, so hit the pause. Give the next one a try, and then I'll go over it. We're solving for R here because I want to buy this car 3 years from now, so I want to save up enough money so I don't have to have a car payment. So the car's going to be $19,000. That's how much I think I'm going to need. T is 3. I've got my interest rate, and I'm compounding monthly. So I'm plugging in 12 for N. I'm going to type in my calculator. The numerator gives me crazy decimal that starts with 0.2. The denominator gives me a crazy decimal that starts with 0.005. I divide those things out, get another crazy decimal. Do not round. And my last step is to divide by my crazy decimal, that 39.39. I'm going to divide both sides by that number, that crazy number. Don't round. And I get my final answer.